Hello students, in this video I'm going to use the possibility and the tree diagram to solve questions 20 and questions 23 from assignment 2A. Right, let's look at question 20. Basically there are two bets. The first one contains 3 cards and they're numbered 1, 3 and 5. The second bet contains also 3 cards but they're numbered 1, 2 and 7. So one card is drawn at random from each bet, and we are asked to display all the possible outcomes of this experiment using a tree diagram. Right, so we've learned earlier on that the branches of the tree diagram actually represent the outcomes. Right, so we're going to start off with the first bet, and it has 3 cards. So the 3 cards will represent the 3 branches of your tree diagram. And the first column will represent bet A. The second columns will represent the second bet, and the second bet contains 3 cards also, number 1, 2, and 7. Right, so the possible outcomes will be you can draw the card that's number 1 from the first bet, and also the number 1 from the second bet. So that is one possible outcome. The second one will be you draw 1 from the first bet and 2 from the second bet. And the third one could be 1 from the first bet and 7 from the second bet, and so on and so forth. So as listed on the screens, it's possible to have 1, 2, 3, 4, 5, 6, 7, 8, 9 equally outcomes. Right, so we're going to use this tree diagram to help us solve some problems. Right, if you look at part A, we are asked to find the probability where the 2 numbers obtained are both odd number. So what are odd number? Odd number basically are 1, 3, 5, 7, 9, 11, so on and so forth. So those are the odd number. So from the tree diagram, we can see that yes, all the ones that's highlighted in yellows are all odd numbers, and there are 1, 2, 3, 4, 5, 6 out of 9 cases. So the probability is 2/3. For part B, you're asked to find the probability whether both numbers are prime. And what are prime number? The smallest prime is the number 2. So prime number basically has 2 different factors, 1 at itself. So the smallest prime number is 2, followed by 3, 5, 7, 11, 13, and so on and so forth. So from the diagram, we can see that the one highlighted in blue comprises of prime numbers, and there are 4 out of 9 cases. Alright, let's look at part C. Part C, we're asked to find a sum. That means basically you just add these 2 numbers up, and this 2 number must be more than 4. So let's look at what are the possible combinations. Alright, so the one with the 6 are the one that when you add both numbers, they will give you more than 4. For example, like this case here, 1 plus 7 gives you 8, and 8 of course is more than 4. And the second case here, 3 plus 2 is 5, so 5 is more than 4. Right, so they are a total of there is a total of 1, 2, 3, 4, 5, 6 out of 9. So the probability is 2/3. Alright, so the next one is we want a sum that is even. Right, so even means you just take this 2 number, add up to get even. So this is one possibility that will give you even number. A second possibility will be this: 1 plus 7 is 8, which is an even number. 3 plus 1, 4 even. 3 plus 7, 10 even. 5 plus 1, 6 even. 5 plus 7, 12 even. So the one circled will be 1, 2, 3, 4, 5, 6. 6 cases also out of 9, which is 2/3. Alright. Okay, the next one is we need to find part E, a product that is a prime. So we just multiply the two numbers together to get a prime. So of course the first one is not 1 times 1 is 1, but 1 is not a prime. 1 times 2, yes, that will be a prime number. 1 times 7, yes, that's also a prime number. So the one that it's boxed up will gives you prime number. So there are 4 out of 9 cases. Alright, let's look at F. For part F, we need to find a product that's greater than 20. So let's see what. Okay, so from the 9 cases there, we see that 3 and 7, right? If you take 3 times 7 gives you 21. 21 is more than 20. 5 times 7, 35, more than 20. So that's only 2 cases out of 9. Right, for part G, the 2 possible outcomes will be 1, 7. The 3 possible outcomes will be 1, 7, 3, 7, and 5, 7. Because 1 times 7 will give you 7, and 7 is clearly divisible by 7. 3 times 7, 21 is also clearly divisible by 7, and 5 times 7, 35 is also divisible by 7. So there are 3 out of 9, which is 1/3. Alright, let's look at question 23. Question 23, it's slightly more challenging because it actually involved 3 dice. Okay, 2 fair tetrahedral dice, and then followed by another 6-sided die. So they're rolled simultaneously. Okay, these 3 different, two fair 4-sided dice, and then a fair 6-sided dice. So the 3 of them, and then you roll them simultaneously. So the numbers on the tetrahedral dice are numbered 1, 2, 3, and 4, whereas on the 6-sided die, it's labeled 1, 2, 3, 4, 5, and 6. So what is the probability that the score on the 6-sided die is greater than the sum of the scores on the 2 tetrahedral dice? Alright, so we're going to use this one. We can't actually use the possibility diagram because it involves 3 dice. So we're going to use a tree diagram instead. Okay, so this question is slightly challenging. So what I'm going to do is I'm going to break it up into 2 parts. That is, we need to find the sum for the first 2 tetrahedral dice. Find the sum for these 2 first. So I'm going to draw the tree diagram for these 2 tetrahedral dice first, and then find the sum. And after that, I'm going to add the branch for the 6-sided dice. Okay, right. So for the first 2 tetrahedral dice, let's look at how the tree diagrams looks like. So basically, there are 4 branches because they represent the 4 outcomes. It's labeled 1, 2, 3, 4. So that is your first tetrahedral dice. And then the second column represent the second tetrahedral dice. Okay, so I'm going to find the sum, right? So what we will have here, it's 1, 1, right? Here will be 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, so on and so forth, right? So I'm going to find the sum for these outcomes. So the sum will just take 1 plus 1 gives you 2, 1 plus 2 gives you 3, so on and so forth. Right, so let's find the sum first. Alright, so you see that there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possible outcomes. Okay, when you roll the first and the second tetrahedral dice simultaneously. Alright, so I'm going to add the branch for the 6-sided die. Okay, because I need to compare Okay, I need to compare this sum that I found, right? I need to compare this sum that I found with the number you're going to obtain when you roll the six-sided die. So the six-sided die has 6 phases, 6 outcomes. So it means we have 6 branches for it. Okay, right. So what is happening is from this first branch here, I can have 2, 1, right, which is what I have here, 2, 1. And then this one, this, and this, I can have 2, 2, right? And let me do another one for you. This, and this will give you 2, 3, right? And so on and so forth, right? And then you can go on to the sum. How you get 3 here? Remember, we take 1 plus 2 to give you 3. And this 3 can form an outcome with, again, back with the 1, you can draw another 6 branches here. 1, 2, 3, 4, 5, 6. Right, so you can form another outcome with 1. So that will give you 3, 1, 3, 2, 3, 3, so on and so forth, right? So similarly for the sum 4 as a sum, you can form a outcomes 4, 1, 4, 2, so on and so forth. Right, so we're not going to do for all the 5, 3, 4 because we just need to make sure that the number on the six-sided die, the number basically this number, okay, we want that number to be more than the sum. So if you look at the first row here, the possible outcome will be the one highlighted in blue, right? Because 3 is more than 2, 4 is more than 2, 5 is more than 2, 6 is more than 2. And for the sum 3, of course, the one highlighted will be 3, 4, 3, 5, 3, 6. And for 4 will be 4, 5, 4, 6. So for 5, we will choose 5, 6, right? Okay, and 3, of course, we will choose 3, 4, 3, 5, 3, 6. All right, 4 will be 4, 5, 4, 6. And 5 will be 5, 6. And of course, for the number 8, there's no case at all because 8 is more than 6. We want the number on the six-sided die to be more. So 8 to be more than 6. So this is not our interest. This is also not our interest. 6 is also not our interest. This is also not our interest. Okay, right. So the one that we are interested in are the one highlighted in blue, and there are 20 cases altogether. Right. So what are the, how big is the sample space? So just now we calculated that when we roll the 2 tetrahedral dice together, there's 16 cases, right? And then if you're going to roll it again with the 6-sided dice, altogether there will be 16 times 6. Gives you the total sample space when you roll these 3 dice together. So therefore, the probability of getting the number on the 6-sided dice to be more than the sum of the first 2 tetrahedral dice will be 5 out of 24. Right, so this is how you do this very complicated and rather challenging questions.